A new study was published, and the internet held its breath. The subject was the magma chamber beneath Yellowstone, and the study hinted at something terrifying, that the monster was bigger, wetter, and more volatile than our instruments had ever told us. This is a system that, if it fails, has the potential to end civilization as we know it. One volcano, with the power to plunge the world into a nuclear winter, to bury half a continent in ash, to rewrite the map of North America, permanently. And yet, right now, today, the official alert level from the United States Geological Survey is normal. The aviation color code is green, the lowest possible state of readiness. Not a warning, not an advisory, not even a watch. Normal. Before we get into the science, I have a question for you. What is the first word that comes to mind when you hear Yellowstone? One word. Let me know in the comments below. Let's begin. And one more thing, quickly. We get thousands of viewers who love these deep dives, but forget one crucial step. Hitting subscribe. It's the one button that ensures we can keep making these. For a small channel like ours, that button is our life support. An emergency button. Please, don't be one of the people who watches, loves it, and forgets. Click it now. It matters. So what is the truth? Did a team of geologists just accidentally uncover a hidden trigger for the apocalypse? Or is this the biggest geological false alarm in modern history? To understand the panic, you first have to understand the place. Yellowstone is not a volcano. Not in the way you think. It is not a cone-shaped mountain with a smoky top. It is the volcano. An entire landscape, 34 miles long and 45 miles wide, is the mouth of the beast. The caldera, a collapsed crater so vast you can stand in its center and not even realize where you are. You can drive for an hour and never leave it. This scar on the face of Wyoming, Montana, and Idaho is not a random feature. It is the current location of the Yellowstone hotspot, a relentless plume of hot material rising from deep within the Earth's mantle. For 16 million years, this plume has been stationary, a blowtorch aimed at the underbelly of our continent. But the continent is not stationary. The North American tectonic plate has been slowly, unstoppably, sliding southwest over this torch at the speed your fingernails grow. And with every inch it moves, the torch burns a new hole. The evidence of this journey is written across the state of Idaho, a trail of dead calderas stretching back for hundreds of miles. The Snake River Plain is not a valley. It is a graveyard of past Yellowstones, each one a catastrophic, world-altering eruption. And history tells us that the hotspot saves its biggest work for last. There have been 3 truly titanic eruptions from this system. Eruptions so large they don't just form craters. They cause the ground itself to collapse, swallowing mountains whole. These are VEI-8 eruptions, the highest number on the Volcano Explosivity Index. The first was the Huckleberry Ridge Tuff eruption, 2.1 million years ago. A blast that ejected 2,500 times more ash than the 1980 eruption of Mount St. Helens. It left a caldera larger than the state of Rhode Island. Then came the Mesa Falls Tuff eruption, 1.3 million years ago. The smallest of the 3, but still a certified super eruption. And then, 631,000 years ago, came the last one, the Lava Creek Tuff eruption. It ejected over 1,000 cubic kilometers of rock, ash, and dust into the atmosphere, forming the new caldera we call Yellowstone today, the one that steams and hisses and breathes right below our feet. It is this timeline that feeds the fear. The math seems simple. An eruption at 2.1 million years ago, another at 1.3 million, a gap of about 800,000 years. Then another at 631,000 years ago, a gap of about 700,000 years. It's been over 630,000 years since the last one. So, simple math says, we must be due. It must be overdue. This is the great myth of Yellowstone. A myth that Michael Pollan, the scientist in charge of the Yellowstone Volcano Observatory, is forced to debunk almost daily. Volcanoes, he says, are not like buses. They do not run on a schedule. The average time between events means nothing to a geological system that operates on a scale of millions of years. To a volcano, being a few thousand years late is statistically meaningless. The USGS puts the real, annual probability of another super eruption at 1 in 730,000. Your odds of being hit by a kilometer-wide asteroid are better. The volcano is not overdue. It never was. So why the sudden panic? The story begins on December 1st, 2023. A study is published in the prestigious journal Science. The lead author is Ross Maguire, a seismologist from the University of Illinois Urbana-Champaign. His team had used a new kind of seismic imaging, a technique that acts like a geological MRI, to look deeper and more clearly into the magma reservoir beneath the caldera than ever before. For decades, the scientific consensus had been reassuring. Yes, there was a massive chamber of magma, miles below the surface. But it wasn't a giant tank of molten lava. It was a crystal mush. Imagine a snow cone, a slushy, a block of granite, mostly solid rock, with a small amount of liquid melt trapped in the spaces between the crystals. The estimates were stable. The magma chamber was believed to be about 5 to 15% molten. It was a sleeping giant, but it was deeply asleep. Geologists are confident that a magma body needs to reach at least 50% melt before it can even begin to mobilize for an eruption. 15% was not 50%, not even close. The system was safe, stable, quiescent. So what do you think now? That was the old picture. Knowing the new science is about to be revealed, does that change your perspective? Let me know. Ross Maguire's study took that quiet, stable picture and complicated it. The new, higher-resolution data showed that the magma chamber was not a uniform, homogeneous block. It was patchy, heterogeneous, and in some of those patches, the concentration of liquid melt was significantly higher than anyone had thought. Not 5%, not 15%, but between 16 and 20%. The study didn't find more magma. It found that the existing magma was wetter, soggier in places, than the old models had predicted. The headlines wrote themselves. Vast new magma layer discovered. Yellowstone closer to eruption. The misinterpretation was immediate and global. The fear was that the fuel tank wasn't bigger, but that the fuel inside was more volatile. But here is what the headlines did not tell you. 20% is still not 50%. The study's authors were explicit. The system is still mostly solid. It still does not have enough melt to be eruptible. Ross Maguire himself stated it plainly. We find no evidence that this large magma reservoir is growing or that the system is progressing toward an eruption. The USGS was even blunter. In a statement addressing the runaway rumors, they clarified that the new data does not increase the threat of an eruption in any way. It simply provides a clearer, more complex picture of what the volcano is doing in its normal, non-eruptive state. The panic was based on a misunderstanding of the science, a failure to read past the scary numbers and listen to the scientists who produced them. The rumor was just that. A rumor. The threat level did not change. The alert level stayed green. Nothing had changed about the volcano. Only our picture of it had come into slightly sharper focus. But that begs a more disturbing question. What does normal actually look like at Yellowstone? The answer is terrifying. Normal at Yellowstone is 1,000 to 3,000 earthquakes every single year. The ground beneath the park is in a constant state of agitation. Most of these are microquakes, too small for a person to feel. But some are not. The park is famous for its earthquake swarms, frenzies of hundreds, even thousands of tremors that can last for weeks or months in one concentrated spot. In 2017, the Maple Creek swarm rattled a section of the park with over 2,400 recorded earthquakes over several months. To an outsider, that sounds like a prelude to doom, the ground shaking itself apart. But to the scientists at the YVO, this is business as usual. These swarms are not caused by magma breaking rock and moving towards the surface. They are overwhelmingly caused by water, hot water, and pressurized gases, moving through the fractured, plumbing-like cracks in the Earth's crust. It's the sound of the geyser system working, not the volcano awakening. If you've found this breakdown valuable so far, do us a favor and hit the like button. And if you have a family member who's seen the scary headlines, share this with them. Let's get the facts straight and talk about what normal really means. Normal at Yellowstone is a caldera floor that breathes. It rises and it falls on a scale that defies belief. Using a network of high-precision GPS sensors, scientists can watch the ground level change in real time. Between 1923 and 1984, the center of the caldera rose by over a meter. An area of hundreds of square miles was slowly swelling upwards. Then, in 1985, it reversed. The ground began to sink, or subside. Since 2015, the caldera floor has been falling at a rate of 2 to 3 centimeters per year. This isn't a sign of magma draining away. This is the volcano exhaling. As hydrothermal fluids shift, as gases escape, as the deep plumbing of the system adjusts, the ground above it responds. There are two specific areas inside the caldera, the Sour Creek Dome and the Mallard Lake Dome, that are the epicenters of this movement. They are called resurgent domes, and they have been pushed up by thousands of years of underlying pressure. Watching them is like watching the chest of a sleeping giant rise and fall. Normal at Yellowstone is the constant, violent, beautiful display of hydrothermal activity. Geysers, hot springs, fumaroles, mud pots. There are more here than in the rest of the world combined, and their behavior is a source of endless speculation. Steamboat Geyser, in the Norris Geyser Basin, is the world's tallest active geyser. For years it was mostly dormant. Then, in 2018, it roared back to life. It erupted 32 times that year. In 2019 and 2020, it erupted 48 times each year, shattering all previous records. The internet diagnosed an imminent eruption. Then, just as suddenly, it quieted down. As of mid-2024, its eruption frequency has dropped dramatically. Because Steamboat's behavior has nothing to do with the deep magma chamber. It's a creature of its own shallow, temperamental plumbing system. A change in its activity tells you about the pipes a few hundred feet down, not the monster 5 miles below. I know, I'm asking again. But look, we're deep in the science now, and if you're still here, you're the kind of person we make these videos for. You're part of the team. We need you on the roster. That subscribe button is your jersey. It's a quick click, but it means the world to us and proves you're serious about this stuff. Keeping watch over all this normal chaos is the Yellowstone Volcano Observatory, or YVO. It is not one building. It is a consortium of 9 different institutions, led by the USGS and partnered with universities in Utah and Wyoming, and the National Park Service itself. Men like Michael Polland and his predecessor, Jacob Lowenstern, are the public faces of a vast, silent network of sensors working 24 hours a day, 365 days a year. Their job is to listen to the volcano's every whisper, every tremor, every breath. Their network is one of the most sophisticated volcano monitoring systems on Earth. Dozens of seismometers are buried across the landscape, listening for the faintest earthquakes. A grid of permanent GPS stations measures ground deformation down to the millimeter. Satellites in orbit use radar to map swelling and subsidence across the entire caldera. Instruments sniff the air for changes in volcanic gases like carbon dioxide and sulfur dioxide. They monitor the temperature and chemistry of rivers and hot springs. This network was not built to predict an eruption. It was built to see it coming. A super eruption would not be a surprise. It would not happen overnight. The signs would be unambiguous, and they would likely appear weeks, months, perhaps even years in advance. Scientists know exactly what they would be looking for. The precursors to an eruption are not subtle. First, the earthquakes would have to change, dramatically. Not just another swarm, but thousands of intense quakes, getting progressively shallower, moving closer and closer to the surface. This would be the sound of magma physically breaking its way through the crust, a geological battering ram forcing its path upwards. The ground would be shaking constantly, and getting stronger. Second, the ground deformation would have to go into overdrive. Not a few centimeters of subsidence over a year, but meters of uplift in a matter of weeks. The Sour Creek and Mallard Lake domes would swell like blisters, visible even to the naked eye. The ground itself would be torn apart as it stretched. Third, the gases would have to change. The volcano's breath would become toxic. A massive increase in the output of sulfur dioxide is a classic fingerprint of new, fresh magma rising from the depths. The YVO's gas sniffers would scream in alarm. Fourth, the heat would become intense. The ground temperature would skyrocket. Existing hot springs would boil over. New steam vents, called fumaroles, would blast open in the forest floor. Lakes and rivers would heat up, killing fish. The entire thermal signature of the park would change. None of this is happening. The earthquakes are normal, the ground is sinking slightly, not rising. The gas emissions are stable, the thermal features are within their historic range. The alert level is normal because the volcano is behaving normally. For now. If the super eruption is a statistical ghost, a 1 in 730,000 long shot, does that mean Yellowstone is safe? No. It just means the biggest threat is not the most likely one. The real dangers at Yellowstone are smaller, more frequent, and in some ways, more personal. The most common type of eruption at Yellowstone is not a continent-killing explosion. It is a lava flow. Of the roughly 80 volcanic eruptions that have occurred since the last super eruption, nearly all of them have been slow, thick, effusive flows of rhyolitic lava. These are not fiery fountains. They are creeping, viscous bodies of molten rock that ooze across the landscape, covering everything in a thick blanket of black volcanic glass. The last one happened 70,000 years ago. It formed the Pitchstone Plateau in the southwest corner of the park. If one were to happen today, it would be a major disaster for the national park. Forests would burn, roads would be buried, and a section of the park would be radically reshaped. But it would not send ash across the country. It would not alter the global climate. It would be a regional crisis, not an existential one. But there is a danger at Yellowstone that is far more likely than a lava flow, a hazard that happens on a regular basis and poses a direct and immediate threat to anyone standing in the wrong place at the wrong time. Hydrothermal explosions. These are not volcanic eruptions. They involve no magma. They are steam-driven blasts. Throughout the park, underground reservoirs of water are superheated by the volcanic system below, kept in a liquid state only by the crushing pressure of the rock above them. If that pressure is suddenly released by an earthquake or a change in the water table, that superheated water flashes instantly into steam. It expands to more than 1,500 times its original volume. The result is a titanic explosion of boiling water, mud, and rock, blasting a crater out of the earth. Small hydrothermal blasts happen every few years, but larger ones, capable of creating craters hundreds of meters across, are estimated to occur every few hundred to few thousand years. They are the single most likely catastrophic event to happen at Yellowstone. The northern part of Yellowstone Lake is dotted with the evidence. Mary Bay, a 1.5 mile wide indentation on the lake's shore, was formed by a series of massive hydrothermal explosions about 13,000 years ago. Indian Pond is another such crater. These events are violent, unpredictable, and happen on a human timescale. This is the danger you should actually worry about in Yellowstone. Not the magma, but the steam. Okay, last time, I promise. Probably. If you've made it this far and haven't subscribed, I have to assume you're a geologist, testing our research methods. For everyone else, please, just click the button. It lets us know we should do another deep dive like this. It's really that simple. Thank you. So, the panic was a false alarm. The super eruption is not imminent. The real dangers are smaller, more localized. Does this mean we can relax? That our understanding is complete? The 2023 study by Ross Maguire was not a warning. It was a reminder. A reminder of our own ignorance. For decades, we operated on a picture of the magma chamber that we believed was accurate. A single new technique, a single new data set, revealed that our picture was incomplete, more complex. We learned that the crystal mush was not uniform. What else do we not know? What other complexities are hiding in the data, waiting for a new tool to reveal them? We have built an extraordinary system to watch this volcano. The YVO is a testament to human ingenuity. We watch it breathe. We feel its shivers. We take its temperature. We have created the illusion of control. An illusion that we could see disaster coming with enough time to react. But the volcano operates on a different clock, a geological clock, where centuries are seconds and millennia are minutes. It is a chaotic, ancient system that has destroyed this landscape before, and will do so again. Our 20-year GPS datasets and 100-year earthquake records are a comical blip in the life of a 2-million-year-old supervolcano. The uncomfortable question that the 2023 study forces into the open is not whether the volcano is more dangerous today. It is whether our definition of danger was ever adequate to begin with. Did the study fail to raise the alarm, or did it prove that our alarms, our entire system of understanding, are built to monitor a creature far more complex and far more alien than we ever truly imagined? Yellowstone sits, silent. In winter, blanketed by snow, its steam is the only sign of the fire below. In summer, It is teeming with life, with tourists who stand on the edge of its boiling pools and mistake its breath for beauty. It steams, it shakes, it lives. It is not angry, it is not malicious, it simply is. The real story of Yellowstone is not the monster that might one day awaken. It's the living, breathing, geological marvel that we have the privilege to study, in real time, from what we hope is a safe distance. The risk is not gone. It is just